Okay, hey there. The contest starts in like literally less than 5 seconds, so let's go. Okay, let's just go. Okay, very nice. Maximum possible number by binary concatenation. By the way, I'm here so late because I was eating. I don't know if you can see this. Okay, uh, yeah, just like a pound of ground beef with some vegetables and so on, and I was not able to fit it all down my throat. Right before the contest and so on, so I literally started cooking less than 30 minutes ago, and yeah, so that's kind of the case. All right. Seems to be taking a long time to load this page. Oh my goodness. Okay. Um, let's see this. So we have a. Oh boy. Okay. Well, I was really excited to try to get a 3 out of 4, but all right. We only get a little bit of a difficult challenge this time around. So okay, 2 mediums and 2 hards instead of one easy, 2 mediums and a hard. Okay. Maximum possible number by binary concatenation. You're given an array of integer. Oh, by the way, yeah. Which one is the one that's Okay, it doesn't seem like it. So usually there's two problems, one with like longer constraints and so on. Okay, let's just go. You're given an array of integer nums of size 3. Okay, return the maximum possible number whose binary representation can be formed by concatenating but what the hell? Okay, I would note that the binary representation of a number does not. Okay, I need an example. Nums equals 1, 2, 3, output 30. Why? Concatenate the numbers in the order 3, 2, 1, 2 to get the result, which is the binary representation of 3, right? So essentially, okay, it's just of length 3. So, okay. Either you have like what, like 6 possible cases. Um, okay. I'm debating whether I should find a smart way to do it or not. Otherwise, I just do the dumb way of doing it, which is like I do all 6 cases, right? So it's like a comma b comma c is equal to nums, right? Otherwise, how do I do a binary representation, right? So I do bin, right? So okay, let me just pull out my terminal and just like make sure that we can do things. So Python 3 here, if I do a bin of like 1, then I get 0b1, right? So this onwards, from 2 onwards. Okay, and so we want this, and so how do we convert into an integer? So int of this guy, comma base 2. Okay, that gives me 30. If I do 0b, does that understand that? It does. Okay. If I do bin 1 plus bin 2. Oh, I'm just going to concatenate them as strings. Okay, that's very annoying. Okay. A comma B comma C is equal to bin. Okay, we're going to map nums with binary of the number. Lambda num, we're going to map it to the binary of the number, and then onwards from 2 for nums, right? Then we're going to do case 1 is res is equal to like 0 for a comma b comma c for x comma y comma z in where are all the permutations, right? A comma b comma c. Otherwise we could have, so we're gonna have a comma c comma b, and here we're gonna have b comma a comma c. Jeez, okay. B comma c comma a, and c comma a comma b, and c comma b comma a, right? For each of those, we're gonna do why is it not letting me? Essentially, what we're going to do is what? X plus y plus z as an integer base 2, comma base 2. Res is equal to max of res and this guy, right? Return res, and we're going to set this to float of negative infinity at the very beginning. Okay, does something like this work? I don't even care about efficiency right now, right? So output is 30. Okay, cool. Output is 1296. Okay, does something like this work? Okay, accept it. That's all I care about, right? So problem 1 is usually not about doing things efficiently. There we go. That's all I care about. Okay, Q2, remove methods from project. You're given a project that has n methods numbered from 0 to n minus 1. Okay. You're given two integers n and k and a 2D integer invocations where invocations of I equals AI, BI indicates the method AI that invokes. Okay, so let's look at an example. Okay, so these are just numbers, they're not methods. Okay, what the heck? There's a known bug in method K. Oh my goodness, okay. Method K, along with any method invoked with it, either directly or indirectly, are considered suspicious and we remove them. A group of methods can only be removed if, oh my goodness. A group of methods can only be removed if no method outside the group invokes any method within it. Return an array containing of all the remaining methods after removing all the suspicious methods. You may return the answer in any order. If it is not possible to remove all the suspicious methods, none should be removed. So this feels like, you know, like a BFS where you start from like the buggy function and like see all the ones that it affects, right, until you get to the very end, right? So, but let's look at an explanation. N equals 4, K equals 1, invocations equals this. Output, what the heck is going on, right? So K is equal to 1, Y is 1 even in there, right? Isn't that the suspicious function? Method 2 and method 1 are suspicious. Bro. Method K, along with any method invoked by it, either directly or indirectly, are considered suspicious. Okay. Method 2 and method 1 are suspicious, but they are directly invoked by methods 3 and 0, which are not suspicious. We return all elements without removing anything. Bro, are you kidding me? I thought it was like anything they touch. What? N equals 5, K equals 0. So essentially, okay, here they're building a graph, right? 0, 1, and 2 are suspicious, and they are not directly invoked by any other method. We can remove them. Bro, what? Okay. So essentially, for the K, if it's pointed by anything else, so yeah, invocations are really edges, right? This is a graph problem, okay? It's just a very weirdly phrased graph problem. Okay, I'm gonna eat some ground beef as I do this. K equals 2. 2 points to 0, points to 1. Oh. Okay, okay. What the hell? Can only be removed if no method outside the group if it's outside the group, then there is no method to invoke within the first place. Return an array containing all Okay, this is a very confusingly worded question. You're given, yeah. There's a known bug in method K. Method K, along with any method invoked by it, either directly or indirectly, are considered suspicious and we aim to remove them. So method 1 is suspicious, which I would have thought made 2 suspicious. But since 0 is not suspicious, then I guess freaking 1 is not suspicious. So it's like, you know, you do 2 parsings, right? So it's like from 1, you BFS from 1, and right. So I got to think about how to implement. Oh gosh, how do you implement something like BFS, right? So it's like for something like BFS, it's like, okay, I essentially mark something as visited. So I'm gonna have a infected dictionary, right? Infected is equal to a set with just K in it for now, right? Then here I'm going to have an adjacency list. Invocations u comma v is equal to edge. And these are directed edges, right? So adjacency list of, and these edges don't have costs. Of u. Are the nodes what? The nodes are, yeah, so the nodes were already given them, right? So I points to an empty list, or I in range n, right? Or is it 0 to n minus 1? Yeah, okay, cool. Or maybe we make this a set, right? Okay, I expect them to give me a nice set of edges. Adjacency.append v, right? Okay, so now we have access to an adjacency list, right? Infected is equal to k. Visited is equal to a set. With just k. While length of infected is greater than 0. First of all, this is interesting, right? Because it's like, here we have a non-suspicious method that points to 1. Therefore, 1 is no longer suspicious. But here in this problem, 2 was suspicious and 1 was not. But 2 infected 0, which infected 1 first, right? So it's like, essentially, it's like, once you have infected all the nodes, is there a path to that k node, to the original infected node, from a non-infected path, right? That's essentially what we're trying to figure out. We could also bring something like Dijkstra's into this, where it's like, we make, if a node is infected, it will start making the cost of the edges, you know, like some ridiculous number, like 20, 100 million. And if it is not infected, then it'll be as cost as 0, right? And it's like for each node, we find like the shortest path. Then we'd have to make it double directed. Okay, there are ways and so on, but this is Q2. Usually Q2 is not that complicated, right? So, okay, let's think of how to do this a bit more easily, right? And the remaining problems are hard. So we can read them quickly if they're short. Okay. Okay, this is not a trivial problem, or not a short problem. What about the last one? Okay. Okay. So some stuff, right? Okay, but we'll get to those problems. Okay, so let's go back into this. Well, length of infected is greater than 0. Infected is equal to set. Q is equal to just k. Collections.dec with just k. Greater than 0. Node is equal to q dot pop left. If node and visited, continue. Visited.add node, infected.add node. Right. Sorry. Visited. Right here, so we can print infected. Return. Return, what do we return? Some list, right? So let's return nothing for now. Return. Okay. I just want to be in full debug mode. Okay, bro, please. Infected, not injected. Okay, sorry about that. Well, please. Okay. Started out, 1 and 2 are infected, right? So this is good. 1 and 2 are infected. Then from here, we have 0. 0 should be infecting 1 and 2. Right? So they should be infecting... Oh yeah, 0 itself is infected as well, right? And then it's like, okay, the only thing is I don't know. So essentially it's like you want like, you know, like connected components. And right? And in this last problem, we get 0 and 2. And this is, well, this is bad. 2 points to 0, which points to 1. Right, so 1 should also be affected. One points to 2. So we pop 2. Node invisited, continue. Wait. Okay, it's not invisited. Visit add node, infected add node. For neighbor and adjacency, that's k. Oh, why am I doing k? I'm supposed to be doing node here. Okay, so now we have 2, 0, and 1. Now we have 0, 1, and 2, which is good. And here we have 1 and 2, which is good. Okay. So now we've essentially formed a little group, right? So infected. So then I can do for I in range right? For I in range length of n if I in for node, if node infected, not injected, infected, then continue. Otherwise, if node is infected, then yeah, continue. Otherwise, it is a non-infected node. Does it reach any of the nodes that are infected? And it's like that makes it not suspicious. Ooh. Oh, wait, so 0 pointing to 1 made 1 not suspicious, but did that not transitively make 2 unsuspicious? What if I did the same test case? Will it not give me the expected result? Oh my gosh, that's really annoying. Okay, because I don't understand this function otherwise. That's really annoying. Method 2 and 1 are not suspicious, but they're directly invoked by method 3 and not. We return all elements without removing anything. Right? I don't understand. Maybe I should have infected as a list. So that way I keep track of the order here. Pen node keeps ordering. Right? So here we have 1 and then 2. Here we have 0, then 2, then 1. 0, and 2, and 1. Oh, okay. Well, that's not really telling, right? But still, technically, it's like a topological sort. Two, 0, and 1. Okay, this is good. So the point is like, okay. If no method, so does this mean that like, okay, if I got rid of this method 3, do I still get rid of both 1 and 2, or do I get rid of just 1, right? Or if I got rid of the 0, do I get rid of just 2 and like keep 1 alone? Like that's what I don't get. A group of methods can only be removed if no method outside the group invokes any methods within it. Okay, so I think it's like even if I removed the 0 here, because 3 points to this one, these are now safe. Again, I'm just going to get an incorrect submission here because I just don't get the problem. But I guess that's what it would mean, right? So if anything is touched in here, right? So essentially I really have one group, right? Infected, right? Because it's just a DFS of everything I was able to possibly infect. Right? I essentially BFS from my node, from my 1, to infect everything I could possibly infect. And then for every non-infected node, so here I return everything. Here I just return everything except infected. Here they're all infected, right? Or I should have called infected suspicious, right? But I'm just thinking in terms of infections. Okay, for node in range like that. Initially infected is equal to visited. Initially infected. Continue. Otherwise, the node is not infected, right? So does it point to any single node in the infected? Or neighbor in node? If node not in infected, in initial, if neighbor in initially infected, return range of n. Otherwise, return for I in range n if I not in initially infected. Range n. Oh, please, 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 please. Okay. In adjacency list of node. Okay. 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 Did I spell this wrong? Initially, oh my goodness. Okay. So here I returned 0, 1, 2, 3. Then here did I return 3, 4? I did return 3, 4. And then here did I return empty? I did return empty. But here's the thing, like I might still return a wrong solution because again, I just don't know if I misinterpreted the problem or not. This is just not gonna be cool. Okay, I mean, let's submit it and try it, but it's just not cool. Oh, okay, that means I did get it. Okay, very nice. Oh, okay, sweet. So essentially, that is what it meant, right? So it's just like, if any non-infected node initially is pointing to one of the nodes inside of the infected group, then okay, they're all non-infected and GG. Okay, so Q2 is usually typically not that bad. So okay, that means we were able to solve it. Very nice. Okay, nice. All right. Let's read this Q3 as I ingest some beautiful part of my pound of ground beef, right? By the way, if you're wondering what that's about, sorry. I have like a new roommate who's like super buff, super costaud, and all that fun stuff. Who's like kind of showing me how he eats and so on and works out and whatever, and it's making me motivated to like like work out with him and so on, like build a better version of myself. So just like I'm building a better version of myself with LeetCode, I'm looking to build a better version of myself physically with my body and so on. And so that starts with both my diet and my workout routine. So yeah, I was just not able to fit this in right before this weekly contest between the daily and this contest. And I didn't eat lunch yesterday because there was the game between the Washington Dogs against the University of Michigan, and I live here in Seattle and so on, and so I went to go see one of my colleagues who was doing a tailgate over there, and so that was a bunch of fun. But yeah, that's why I'm eating all this right now. So let's go. You're given a 2D integer array edges representing an undirected graph having n nodes where edges of I is equal to UI VI denotes an edge between nodes UI and VI. Okay, cool. Construct a 2D grid that satisfies these conditions. The grid contains all nodes from 0 to n minus 1. Oh god, okay. That's for 0 to n minus 1 in cells, with each node appearing exactly once. 2 nodes should be in adjacent grid cells horizontally if and only if there is an edge between them and edges. It is guaranteed that edges can form. So is this just... Oh, no. Okay, I was gonna say, is this just like a 2D grid where it's just like one if it's an edge and so on? Okay. It's guaranteed that edges can form a 2D... Return a 2D array that... Okay. Okay, let's look at an example because I do not understand that question. N and edge is equal to this. Output 3, 1. X... Bro. Are you serious right now? Oh. Okay, sorry. I hope that you can still hear me. This guy just got activated on my computer. Okay, so that is annoying. Okay. I need to find a way to disable that, right? Because it's actually kind of bothered me a few times while I was doing my calls with my buddies and all that stuff. So not cool. I hope that you guys still hear me. Otherwise, it's gonna be very, very awkward. Okay. N is equal to 4. Edge is equal to this. Okay, so I just need to read the question better. Otherwise, we can also try the last question, right? So let's read this one carefully as well. You're given an integer array nums of length n, an integer array queries. Let GCD pairs denote an array obtained by calculating the GCD of all possible pairs of nums. Okay. Sorting these values. Okay, geez. Okay, so nums. Okay. For each query, you need to find the element at index queries. Bro, what? Okay. Return an integer array answer where answer of I. Bro. Two, 3, 4, query 0. Okay. Output 1, 2, 2. Explanation. GCD pairs is equal to GCD of nums 0, nums 1, nums 0, nums 2, nums 1, nums 2 is equal to 1, 2, 1. After sorting them, that is 1, 1, 2. Obviously, it's probably not going to let me sort stuff in place, right? So let's look at this. Actually, okay. 10 to the 5 means that I can actually take an array, populate it, and just do n log n, right? It's just that what is the time complexity of doing math.gcd? I actually have no idea, so maybe that's what's not going to be allowed. Okay, so this problem is probably going to be like identifying like when GCD actually returns a lower number and so on. Okay, so it's going to be math stuff that I probably don't understand. Return an integer array where answer of I is the value of GCD. Okay, so let's look at this example. After sorting in, so the answer is queries of 0 is what? 0. Okay. GCD pairs is equal to math.gcd of nums of I, comma nums of j for I in range length of nums, for j in range I plus 1, comma length of nums. Sorted of this guy. Return CD pairs of queries of I for I in range length of n. For I in range length of nums. Right, so like this is the direct answer, right? So like here we return 1, 2, 2. Here we return 4, 2, 1, 1. And here we return 2 and 2, right? But there's, does this even list index out of range? What the hell? Print GCD pairs just to make sure that I'm doing stuff right. Here is 1, 1, 2. Here is it 1, 1, 1, 2, 2, 4. And then here it would be is this queries? Yeah, okay. Okay, so let's submit this. And what, this time limit exceeded is what you're telling me? Essentially, it's like I need to be able to do like some magic, like binary searching or something like that, and so on, as I need, right? So yeah, or memory limit exceeded. Okay. So maybe it's like, you know, I can extend nums. GCD pairs dot sort. For I in range, length queries of I is equal to GCD pairs of queries of I, return queries. So here, yeah. Just that way I don't use this extra memory if I don't have to. But otherwise, yeah, that's the point. It's like we're gonna have a correct solution. That's just gonna be either memory limit exceeded or time limit exceeded. It shouldn't be time limit exceeded, okay. But the point is memory limit exceeded, right? So we're gonna need an efficient way to do this stuff and so on. So it's like, essentially like I should sort nums, right? And then it's like figure out what GCD actually means and blah, 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 and so on. So it's just like, I'm gonna need to do some smart stuff. For now, we might as well move on to question 3 and figure out if we can do something there. And just continue onwards, right? Okay. 2D represent an undirected graph having endnodes, right? Where, yeah, there's an edge between UI and VI. Cool. Construct a 2D grid that satisfies these conditions. The grid contains all nodes from 0 to n-1 and its cells, with each node appearing exactly once. 2 nodes should be in adjacent grid cells, horizontally or vertically, if and only if there is an edge between them and edges. Oh, okay. So it's not just like if, it's only if as well, right? Interesting. So number of edges in n are both n log n-able. A 2D grid, it can be any 2D grid. So obviously I should think about this as a graph, right? Can I not just do like a topological sort? Shoot. I also need to remember how to do a topological sort. Is it cheating if I look that up? It probably is, right? Because this is a contest. I'm probably not allowed to look things up. Okay. If someone knows the answer to that, by the way, let me down in the comment. I won't look up how to do topological sort, but if it is legal for us to search stuff up during the contest, then let me know and I'll know that for next time. But okay. Topological sort, so let's think about it, right? We essentially want all the n degrees. We want something with an n degree of 0, right? Oh gosh. It's just like, I just need to watch that like 60-second short by Nico just to remember how it's done. Essentially, you have all the n degrees of length 0. You add that to the list, and then it's like each of the neighbors there, you decrement it by 1, right? So here we're going to build an adjacency list. This for u comma v in edges, comma this for I in range n. Whoops, for I in range n. View that append v, just see list of v that append u. Right, I'm just gonna assume that they don't give me an annoying edges thing, right? Print adjacency list. 0 points to 1 and 2. 1 points to 3. Oh, and 0 is, yeah. 2 points to 0 and 3. 3 points to 1 and 2, right? So we need a topological sort of these algorithms, right? So how do I topologically sort? It's like, I need in degrees, right? I'm trying to think, how do you... If something has an in degree of 0, right? It can essentially be the parent of anything in a topological sort. And also, the fact that this is undirected is kind of nice. The only tricky part is the if and only if, right? So it's like, you also got to think about relationships backwards. But if we have a topological sort, you know, we can just directly query, like, oh, is there an edge between these two? No. Yeah, so we can essentially do a topological sort, right? And it's like, okay, if something is not there, then it's like, okay, we're just going to fill the rest with zeros and just make things nice, right? So if I can figure out how to do topological sort, this is easy. And usually, like, there's a 60-second short by LeetCode and so on that whenever I watch it, I just remember instantly how to do topological sort. But right now, if I queried that, that would probably be cheating. And I don't know if it is cheating or not, and so I don't want to find out the hard way. So let's try to see if we can come up with topological sort on our own. This is going to be annoying. I should probably compute the in degrees of every node, right? So maybe for now I'll just make this a set, and I'll make this dot add. Right? Okay, I gotta think. It's in degree. Since this is in undirected, right? What is the in degree of 1? It's gonna be 2, right? 0 and 3 both point to 1, right? Because not only is it the edges that it points to, it's the ones that point to it back, right? So essentially here, any ordering works. In fact, I need them to all be touching. Right, so it's like, it's gonna be topological sort, but you have to figure out how much are touching who, and so on, right? So it's not just a normal topological sort, it's a bit more. Right, but it gives you a good order of how to place the elements inside the grid. It must be so that they all fit. So if you can't have 9 in the same group, right? Because it doesn't matter how much you do 9. The middle one will touch everything, but everything else will not be able to touch, right? So maybe this is a telling example where it's like, here, I cannot have a 5th element, right? It doesn't matter where I put this 5th element. It cannot touch everyone at once. So maybe groups of 4 is the max, right? Something like this. Something like this is possible, but then it's like 5 is not touching 8. Okay, maybe this really is a LeetCode hard. I gotta think about this here. I'm still convinced that something like topological sort would be very useful here. Right? Like if I do topological sort, see what it returns me here. Let's think about this. Right? In degrees. Right? And so now let's print in degrees. I can probably use a heap here. In degrees equal to length of adjacency list of node, right, comma the node itself for node in range n, and heap q dot heapify in degrees. Then this will be something like the actions, right, where it's like visited. Well, length of visited is less than n. In degree, comma node equals heap q dot heap pop from in degrees, node in visited, continue. Otherwise, we're going to do visited dot add node, right? And it's like, okay, so we just found the node with the smallest in degree, right? So here we're going to do topological sort array is equal to this. Topological sort dot append node. We're not going to only append its node, we're going to append its in degree. Why not? Right? Okay. Now, essentially, everyone is now freed by this node, right? So, okay, I gotta think. So essentially I want to update everything, right? F string top sort equals. Okay. Top sort is equal to this stuff. Okay. So now we'll just do top sort dot append node for now. So here we had 0, 1, 2, 3. Here it actually doesn't matter, right? They were all equal. Or something like this. 0, 1, 2, 3, 4. So it's interesting. So the topological sort already happened to be one of the ways. It's just here that they flipped it, which is actually very interesting. Maybe it's telling of something. And now let's look at the last case. So this is what I mean. There's something we can infer. Right, so here 8 must touch 7. 7 must not touch 6. Okay. So 1, 0, 5, 2, 3. So 1, 0, 5, 2, 3, 4, 6, 7, 8. That is a very interesting pattern. Does it work in all of the ones? So for example here, we could have done 0, 1, 2, and then 3. So it's like here they go this way, they go this way. Then there's just, you fill the bottom row, fill it up as much as you can. So there's something interesting, right? It could also be that I did a topological sort wrong, right? Is this even a valid topological sort? It should be, right? It's essentially like the in degrees and so on, and then whenever I add something to my topological sort, I kind of free the rest from having to be chained by that one thing, right? Or actually, or degree greater than 0. Length of in degrees equals 0, break. Top sort. Oh, this does make sense, right? Maybe this is just gonna. You can't really topologically sort in a graph like this, right? Every node is pointing to each other. It's like everything is a parent of the other. So you can't really top sort that. You can't really top sort that. You can't really top sort that. Okay. So this makes this problem a little annoying. So, essentially for each number, it can be adjacent to up to 4 numbers, right? Print f string of in degrees dict is equal to. Maybe this is like a backtracking solution, right? Where it's like, okay, each node essentially has 4 available spots. Top, down, below, and left, right? And we can essentially assign them -1 if they're not filled. Right? And that's like, okay, we try filling a node somewhere. I'm not very good at backtracking though. Sorry, I'm just eating my meat here. Okay. So this is a little bit of a frustrating problem, but okay. Essentially, it's like, there's something special about this 4x4 here, right? Because it's like, you notice anything that's bigger than 4x4, it's like, you know, you have 5 and 8 not touching, 5 and 7 not touching, 6 and 7 not touching. So like a node cannot have more than 4 neighbors, right? Because otherwise it would be impossible. Right, that's just a realization I'm making. So that's very interesting, right? It's almost like we can give everything like up to 4 spots to satisfy. So maybe it's like we draw a map. Maybe we just like, you know, we give everything positions, right? It's like even if we give positions to stuff and, you know, we end up with 0, 0 as the origin and like we have like 2 1s and so on, we can just do a shift. Like, you know, we have like -1, 0 and so on. We shift every number by whatever's the lowest number, and then it's like, you know, create a grid that has up to that and so on, and then there you go, right? It just needs to be any 2D grid. There's no max size in this grid. Or can you not have -1 cells or whatever, right? Is that the thing? Okay, so it's gonna be a 2D grid with exactly up to n cells. So once you pick a row or a column height, you commit to that boy. And maybe that's dictated by the length of the longest in degrees. Right, so this one has a relationship of 3. This guy needs to be looking at 3 things. One is looking at 2. So if something is touching only 2 things. Okay, and also, can things be touching nothing? So there's at least 2 nodes. There's at least 1 edge between those 2 nodes and so on. Or is this like a strongly connected graph? So it's like, yeah, 0 should be there. That's like, for example, like you have to think. Okay, so you can have at most 4, right? So really your row length should be at most 4. Or your column length, right? So that should be at most 4. Or really, it's like, no, because you could just have an infinite amount of columns like this, right? If you have, I really wish there were more examples here, right? If you have a 4 like this, right? This 4 has 4 adjacents, right? Which is the absolute max you could ever have, right? Because you can only be adjacent to 4 things. Then it's like, okay, if anything else is adjacent to that 4, it's like you put another 4 like this, and that's how you get another column. But the fact that it needs to be 2D is very interesting, right? Because if something has right. This is very interesting, right? So I only have 35 minutes. Am I really gonna get a 2 out of 4 again in this one? This is a shame, right? We can also look at this by obtaining the. I don't know which one is easier between these 2 hard problems. So GCD, how do you do it? It's like you do like A modulo B all the time, blah blah blah. I don't know the complexity of that boy. But we could do something like, you know, nums.sort, so maybe that helps us out, right? So it's like we could do a figurative sorting. So how do we get a memory limit exceeded here, right? Nums.length is up to 10 to the 5, so that we cannot use n log n space or something. 10 to the 5, 10 to the 5, and it's like, yeah, you start exceeding a little bit too much memory. Yeah. So this is not really the problem here, right? Here we're just transforming everything in queries, right? It's like, is there a way to binary search essentially inside of GCD pairs? It's like, is there a pattern, right? So this is 1, 2, 1. So nums, you have 2, 3, 4. 0, 1, 0, 0, 2 was the biggest, right? So 2 and 4 have the biggest, greatest common denominator. Is that usually going to be whenever there's the biggest discrepancy? It's like, yeah, you need a way to essentially, like, you know, have this figuratively sorted in your mind to be able to query. To binary search this, right? That's how you make a relationship, because GCD is a very weird thing to make a relationship based off. Print GCD pairs. Yeah, let's move myself over here. So this was already sorted. Is it really just biggest discrepancy? No, that's got to be a coincidence. Well, here I sorted numbers. Hold up. By sorting numbers, GCD pairs was already good. That's a very interesting realization. Or actually, no, here it's not, right? But surely sorting the numbers doesn't hurt. If I sort the numbers, right? So GCD of 1 and what? You have 4 and 4. So the bigger the numbers are together, you know, that's good. Numbers are close to one another, or half of one another. Just makes it very interesting, right? GCD is a very weird one to make like indexing off of. Right? It's like, how do you even query for stuff? How do you binary search through things here? Whoops, that's not what I want. Just very interesting. Okay, we can go back to this. This might be another like 2 out of 4 day week. It would be nice if we got 3 out of 4, because then that means we would have made progress. And it's a shame, right? There's 2 questions that we get to spend a lot of time on, and we might not get to get to any of them, right? Okay, so for this one, there's something that is very interesting, right? So you can have at most 4. So it's like if you have n is equal to, you know, like 10 to the 4, right? If n is that large, right? Depends on the maximum degree. So maybe it's like, you know, you sort them decreasing by n degrees, and then you add them. And it's like whenever you add another one, it's like, okay, if there's something in there, okay, maybe we have like an added set, right? So here's like we have an placed is equal to set, right? And n degrees dict is equal to this. Whoa. In degrees is equal to sorted. Reverse is equal to true. Key equals lambda pair at index 1, right? We're going to do this in its position. Right, so essentially it's like we need to take a number, right? So the first one we're going to grab is like 4, right? And we're going to place 4 because it's not been placed, right? Then we're going to loop through all of its numbers, right? And for each one of them, it's like we're going to place it if it's never been placed before, right? And it's like we're going to keep track of those coordinates, right? And then it's like we're going to keep going by like highest in degree, right? Because those are the most important. And we got to make sure we place it in a spot where it will leave them the most available remaining spots, right? So taken positions, right? So some idea like that. Okay, so can I code this up in like 26 minutes is the question. That is that, because this is going to be like quite a bit of code, right? For node, comma, in degree, and in degrees. Node not in placed. Oh gosh, this is annoying, right? So it's like I need to place my original one. So it's like really I need to place all the ones of with in degree 4, right? It's like if it needs to be separated, it needs to be separated. So they need to be like on my diagonal or something. Oh man. This is not an easy one. And with 24 minutes, I don't know if I'm gonna be able to get a solution. There's gonna be some trick here. I can start with the one with the highest in degree. Place that first, right? And that's like for each of those, it's like getting a place its neighbors. Right? So in degrees of 0, comma, in degree, node, comma, this is equal to n degrees of 0. Node, we're going to set this to be 0, 0. That's its position. And then the remaining positions are going to be -1, 0, 1, 0, 0, 1, 0, -1. Or actually, we're gonna have taken positions, right? So this is gonna be 0, 0. So yeah, we're just gonna do this. Place is equal to a dictionary with originally node is point to 0, 0. And then taken positions will start as a set. Actually, yeah, so if a position is 9 taken positions, then it's available for grabs. That's how we're gonna do it, right? So okay, so taken positions dot add 0, 0. And we can even say who took it, right? So we can make this a hash map of 0, 0 is equal to node. Right? So then, otherwise, we need to place the node, right? So we need to place the node around its in degree, right? So we want to find the position that frees up the most amount of space. Pause is equal to self.get best position with node. Take the adjacency list. Take taken positions. So it can be a new position, right? Ugh, this is really annoying. This is really, really annoying. It could be a new position, which is like what I was trying to avoid with the first case, where it's like I put something, you know, like at the origin on my figurative map here. So maybe it's like, yeah, I just keep adding stuff to the diagonals, right? So it's like whenever I have something that's just like I cannot place around me, that means I need a new diagonal, right? So that means I need one more row of dimension. Actually, that might work, right? So we start off with diag at 0, 0, right? Okay. Maybe we do something like that. So here it's like, scratch this, right? Diag is equal to 0, 0. Right? And so for node and in degrees, E is equal to, yeah, pause is equal to start get best pause. Or just instantly, yeah, okay. So essentially it's like the one that's the least restricted, right? Right, because again, we're going in order of in degrees originally, right? So it's like, might as well be greedy. If something has the biggest in degrees, you want to give it the best possible spot that I can have, right? Or one that's been taken. Its surrounding elements have to either be untaken or part of the answer, right? Okay, yeah. Yeah. So node is not in place. There's at most 4 neighbors, right? Assert length of adjacency list of node is less than or equal to 4. For neighbor and adjacency list of node, yeah, it's just this is stressing me out, the 18 minutes here. I really want to solve this. If node is in place, then continue. Assert length of adjacent. Yeah, okay. If neighbor in placed, right? So it needs to be placed here, right? We must place it around here. Have not placed our node, so pick a new position, a diag, and then update diag. Placed of node is equal to diag. Taken positions that add diag of diag is equal to node. X comma y is equal to diag. Diag is equal to x plus 1, y plus 1. Diag x, diag y. Diag x, diag y, right? So it's like introduce a new diagonal whenever I need to add a brand new element, right? And I start with the max in degrees and so on, so this is good. And the point is, like, everything, I will have negative positions and so on, but at the end I will shift everything so that they are all valid, right? Because I'll have essentially like a connected like grid, right? And then it's like, okay, shift everything to valid indices. And that's essentially how I do things, right? Okay, neighbor is in placed, right? So if neighbor is in placed, then we need to place it around that neighbor. This neighbor, since they are connected, we must find the best spot around this neighbor to place this node in. There are at most 4 valid positions. We must pick the best one. Positions is equal to, well, the neighbor's taking position, right? So placed of neighbor and x comma y plus 1, right? So that's essentially the 4 possible spots I can put. equals we're going to filter this with a function here. Pause not in taken positions. Right, so there we go. So we filter first of all the ones that are not in taken positions. Assert length of positions is greater than 0, so there must be at least one. Position in position for pause in positions. Okay, we don't even need to do a filter object, right? So here, let's just do positions is equal to this guy. For pause in positions. If here we'll do assert false to make sure that we've at least taken one position. Here we'll comment this out. Should not reach here. If, okay, I have 13 minutes. Okay, I better be fast. For pause in positions, if something, so pause 9 taken positions, and in taken positions, continue, otherwise pause X, pause Y. Pause X, okay. Pause underscore. Pause, 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 pause. So we want to make sure that these four, okay, so these are the valid spots, right? So we want to make sure that the 4 valid spots around that spot are legal in terms of like they're either untaken, check that all 4 of these spots are either untaken or, if taken, is one of nodes adjacency list neighbors. Either untaken, con is equal to new pause not in taken positions, or else or placed of new pause, right? That position is taken by something in nodes of node, right? So we're gonna place this node, right? So we might as well make sure this, right? Right, so that. If it's still true, if cond in oh my gosh, I have 8 minutes. Cond, then placed of node is equal to not to just this pause, but this pause. Actually, yeah. So we assert false. So if neighbor is in place, right, we must have to be able to place around that neighbor. So here we assert false. Assert placed node is equal to true. Unless placed node. So if, and here this is an else. Right, so, my goodness, this is a long if statement. Oh no. Place node. If placed node is equal to false, so pick a new position. Yeah, okay. So here, essentially, do we have all our nodes placed? This is the main question. Right? Print placed. Return empty array. Unknown network error. Node. Node range n. Nay or that node. Yeah, so they should be taken positions. Ah, gosh. How? So I reach this point if neighbor is in place, right? So I must place it around one of its neighbors. How? I mean, okay, I'm not gonna debug this in 3 minutes, so that's a rip. But it's just like, how? Like, it's like I need to be able to play. Like, they're telling us that like there will be a solution. This is saying that there's not a solution. Like, what the heck? We're gonna place a node. Place node 0. Right, so the point is that like for neighbor and adjacency list node, for each of that node's neighbors, that neighbor's been placed, right? I only go in here if that neighbor's been placed. X comma y is equal to place of neighbor, right? So node to position. For the surrounding positions, right? So for each position in those surrounding positions, that position is taken, then I cannot take it, right? Pos comma x, pos comma y is equal to that position. So for new position, so for surrounding positions of that position that I want to grab, it's going to be these. Either untaken, or if it is taken, it is one of node's adjacency list neighbors, right? Yep, so I'm going to place node, right? New pos, 9 taken positions. Either that new position is not taken, right? Or if it is taken position of that position should map to a node that is one of this guy's neighbors. That's very much true. Cond equals what the heck? Printf cond equals cond. Otherwise, I mean, I'll get rid of the assert, but like, That's 4-4. Okay, I didn't get it, so that is a bummer. Okay, so for this contest I did 2 out of 4. That's a rip. I always do 2 out of 4 and then get stuck on like that Q3 or Q4 and so on. So as always, we can look at how I was able to do the solutions. So, okay, I will just quickly call my friend Noor if he's available and come back whether he's available or not, and then we'll continue this discussion and see essentially how these guys were solved. So I will be in literally back 1 second. Okay, so I'm back. My friend Noor says that he will call me in just a second. Seems like he was able to solve 3 out of 4, so he was able to solve Q3 and not Q4. And he's saying like, okay, question 3 was really hard, but that apparently people were able to solve question 4 so quickly. I need to ask him how he's able to see those times. Yeah, okay, the top guy 15 minutes to solve. Yeah, so I was on Q3, so maybe I should have been able to do Q4 more efficiently. Otherwise, you know, let's try to go here. Let's go into the discussions of the contest. Discuss. So where's the, is it general discussion? Okay. Hey there, Mr. Noor.
Alright, let me see your 2 out of 4.
Yeah, okay. Oh, did I even tell you that I did 2 out of 4, or?
I'm gonna assume, like, I mean, the first one is trivial, right? Like, worse, like, let me show you my solution for Q1. It's like the most retard ooga booga solution you can think of.
Okay. I mean, I did the all 6 cases.
Me too, that's literally what I mean.
It's length 3? Okay.
Like, let me show you how ooga booga, because I told you, right? Q1, like, you just do the most ooga booga way and get it working.
Right.
Let me show you
Why are you
this.
showing me here?
Ready? Look at my Q1.
Oh, there's something else.
Orders.
Wait.
Bin int.
Where is it? Yeah. No. Dude, I did this exact same thing. Don't worry about it.
Yeah, did you solve Q2?
Yeah, I didn't solve Q3 though.
Q3, dude, when you look at the solutions, like it turns out Q3 is a lot harder than Q4. I felt kind of cheated by that.
I was like, okay, I'm either gonna focus my time on Q3 or Q4. Q3 seemed easier than Q4, because Q4 was like, okay, you need to figure out some binary search trick, but doing it on GCD seems kind of weird. So it's like, let me just try to do.
You go to the ranking.
Wait, how do I?
Easier.
Wait. Show me how you got there. I'm trying to see the bro. Okay, like.
Oh, what are you trying to say? What do you want? Here?
How do I do any? Okay, can I share my screen maybe?
Yeah, what do you want to do?
Share my entire screen.
Okay, share your screen, bro.
Am I sharing my screen to you? Oh, now I'm gonna show myself to you. Okay, well that's weird. So I'll put you away for now. Okay. Where do I go, sir?
What are you looking for?
Anything.
Okay, click on contest.
So you click on contest.
Now scroll down. Click on my contest.
I see.
Now you can see how you've been doing.
I see.
So click on the one you just did.
Okay. I can understand this.
Now scroll down. See the rankings.
I see.
Now you can click more on the rankings.
Okay.
Click more. Now here is how you know which question was hard. Look at the top 3 people and look which one they solved last. They always, so you see for this one, they solved Q3. I mean, they solved Q4 at 11 minutes and Q3 at 26 minutes.
I see. For Q3, by the way, one thing I realized is you have at most 4 neighbors for any node, right?
Exactly.
Yeah. But I was trying to do some magic sauce.
No, but... dude, Q3, when I realized, first I was like, okay, I have to try to every combination of grid sizes and then fill it in. And when I realized, hold on, there is a cheat to this. They guarantee you that it'll work. That's the only thing you need to know. They guarantee you that it'll work. So just fucking believe in Jesus Christ. That's all
yes. Do. So I was okay.
You just have to figure out which. All you need is figure out the corner and just build it. Just trust that it'll work.
Oh, a corner. So you did the smallest in degree and then populate from there.
No. There's only one edge case, which is if you have a 1 by n, right? If you have any other grid, only the corners will have 2 connections. Everything else will have 3 or 4. And they tell you the grid will be valid. So you just search the number. You count up the number of connections, right? You're like, oh, this node has only 2 connections. Okay, it's a
I
corner.
see. No, what I was trying to do is maybe
And
it was gonna work. It's just I had an incomplete solution that I didn't finish. Essentially, it's like I sorted them by in degrees decreasing. So it's like, if something has 4 things that are just next to it and so on, like
No, no.
I
Let
started
me show you. It's
first.
actually such a
Okay.
long solution. Ready? Look at my. You're seeing my thing.
No.
Ready? No, I see. You have to.
What?
Oh no, sharing screens are sharing screens. All right, you see my solution?
What?
Ready?
Yeah.
Here is the start of my solution. I'm gonna keep scrolling.
Jeez, dude.
Like it's not like I got the idea, and it's like there's like, dude, this is the edge case, by the way. You know how usually edge cases are one fucking sentence? No, fuck that. Edge case is 1 by n grid. So like here's the idea, right? It's the same thing. So you have like which ones are left, and you start in the corner. So for this case, I detect that it just has to be a 1 by n grid, and the way you detect that is like, oh, okay, only one. Like there's a node that has only 1 connection. How can you have 1 connection? It's a 1 by n grid and you're the corner. You see what I'm saying?
I see. So no. You just had I wonder if mine would have still worked though. Essentially, it's like I generally pick like you just went from the guy with the lowest in degree, and then spread from there. I was doing from the highest in degree and spread from there.
No. It's a very different. The reason mine worked. Let me explain to you. The reason mine works is like what I'm doing, right? I'm putting the corner. And then I'm saying the corner must have 2 connections. Put 1 right, 1 down. I have done the right and the down. Now, what is the right and the down have a connection? This node must be connected to both of them. So just figure out which node is connected to both of them. There's only going to be 1. Otherwise, the grid is not possible.
Right, but again, I'm saying you're just starting with the corner. You're starting the ones with the smallest in degree.
No. But starting with the corner is different because it's guaranteed. You know what I'm saying? Starting in the corner
Right.
means corner.
But
has these
what
two.
like
Because
the
we
one
have
with the
these two,
smallest in degree is gonna be forcibly be at a corner if there is a corner.
Right, but if you're saying
Am I right or am I wrong here? The one with the smallest in degree.
Well, yes, that's fine. Yeah, you get the ones with 2, like 2
Yeah.
connections. I mean, you're only gonna have 1, 2, 3, or 4.
Like
right?
you might as well shove the thing with the smallest in degree at a corner.
Yeah, sure.
And then build from there. Okay, I was essentially trying to build from like the middle and like from the largest in
Yeah,
degree.
that cannot work.
Well, it will work. It's just it'll be annoying to spread. Like at some point, like have negative positions. I just gotta shift everything over and so on. It just makes the work a lot more complicated on a complicated already problem.
Yeah, it's already complicated, and spreading from the middle. The reason it's gonna be really, really tricky because you're gonna have pretty much like a fucking double, like a 2-directional linked list structure. You know what I'm saying?
Right.
Like if you spread from the middle, it's like this has to be connected to this, and this has to be connected to this, connected to this. Oh wait, this has to be connected to this. Somehow fucking reorient the thing. Like it's weird. You know what I mean? You don't know which direction has to happen from the middle.
I see.
Like you have 4 connections, and you don't know which one has to be like.
I didn't.
for example, in life.
I didn't think about believing in Jesus Christ. Maybe I should like convert to Christianity. Like,
No, like the only reason my solution works is like, okay, if they said, like, if it's not possible, return -1, I'm dead. Like that's it. My solution cannot figure that out. It just believes in Jesus Christ and says, like, dude, do you see my thing? Like, do you know when I stop going? Like, you know how you're supposed to do like n by n or something? Here's my condition to stop filling in the row.
huh.
If the loop did not add something to the row, then it must be we finished our job, and like just pray that they all line up. I'm telling you, bro, I just believe in Jesus Christ here. Like,
That's actually so funny.
like, and it works. You know what I mean? Like, because they tell you it's guaranteed. The reason middle doesn't work is because if you have 4 connections, you can flip it, right? Like if I have left, if I'm in the corner and I can have right and down, then if I switch, if I switch those two, all I've done is like flipped it. You know what I mean? Like that's just another valid solution. But if you're in the middle and you have like left, up, right, left and up might make it impossible. You know what I mean?
Mhm.
Like you might need, like it starts mattering.
Makes sense. Did we figure out a solution for Q4?
No, but it's supposed to be a lot easier because a lot of people solve Q4.
Okay.
Q4 is a more, so I don't really understand Q4, but I think it's a divide and conquer.
Right, it has to be. Isn't you essentially?
I was like, shit, I got 10 minutes left because I had no time after Q3. I just fucking tried the Ooga Booga, and obviously it didn't work.
Yeah, I tried it too.
that you have to somehow know. Like, you know how there was a thing we did with divide and conquer where it was like, in an unsorted array, get the mth index. You know what I mean?
Get the mth index. Yes.
Like get index, get the value that's at index k after you sort it, but without actually sorting it. Like you can do that in O of n instead of n.
Wait, you
n log
can?
n.
Is it the oh, what's it called? The
Whatever it was.
wait,
What
it's not quick select. It's like deterministic select.
I don't know, but I forget what it was, but the point
Deselect,
is like
deselect.
you do something with pivots and some shit, and like the point is you don't.
Yeah,
gotta
you
sort
have
the
like
list.
you have like 3/4 on one side, the other 3/4 on one side, kind of thing.
Yeah, exactly.
Yeah, I remember
so
that.
idea has to apply here because what you can't do is do every I and J, but what you have to do.
Bro, there's no way that's the idea, and then a lot of people got it. Like deselect is such a unknown algorithm.
No, okay, well also this is a generic problem, right? Like I feel like there could be cheating, but but like okay, here's the reason I think the top people solved Q4 first is because it's fucking short. Like Q3, dude, like this shit, like I don't think I did it wrong. It's just it has a lot of code to be written. You know what I mean? Like,
Wait, so okay, can we see the people that discuss the solutions? There's usually a discussion area where they say like, "Here's how you would do it."
Let's go to it.
So you go to the contest. Is there go to contest discussion. I see.
All right. All problems so hard. Upvote if you agree.
Prisoner angry. Okay, there's no such thing as a first problem now. Here's the new contest: Q2, Q3, Q4,
Q5. These guys are actually bitching now. They want question 1 to be like, add 1 plus 2. Like, no, question 1 was reasonable. Like, do you know how to use some built-ins?
Actually, yeah, if you don't know int and bin, like KYS for question 1. Well, I guess you just do power of 2 stuff, but yeah. Okay, wait, many ways to do this. Here's mine. There's a vertex with exactly 1 edge. Follow it to the end as a 1 by n. Otherwise, build the top row by string. Yeah, okay, so I should have done lowest in degree first instead of highest in degree. Literally, if I just flipped my mentality, I'd be GG. Okay, that's not infuriating at all.
Like, it was a lot of code even after I figured that out, you know what I mean?
Yeah, but like from that point, I could have figured out. Like the point is that like yeah. Anyways, okay, Q4 classic GCD counting problem and bro, what do you mean classic? Okay, in nlog n, my classical GCD counting problem of the day. It's not even impressive. Okay, nlog n. Okay, first get a frequency count of nums. Oh, nlog n total time. It's just that you won't use that memory limit exceeded. Okay, first get a frequency count of nums. Frequency count of nums. Okay, then traverse. What does that say? G is equal to max val to 1. Getting the total number of pairs that are multiples of G and subtracting GCD for 2G, GG. Build prefix
bro, what the fuck is this classic ass bitch ass idea? This is not classic. There are 3 things being
my classical
together.
morning cup problem of the day. Prefix sum out of my butt cheeks. Oh, I thought.
You know what it is though? It probably is a common thing because like greatest common denominator is such a common idea in math. You know what I mean?
I guess
like,
so.
It's probably a common question in that like applying things together.
For number theory.
This seems to do with combining prefix sum and binary search. So whatever that means, bro.
Bro, you don't know? How can you not know? Okay, I'm just a little mad. Q3 I could have solved it if I just went the opposite direction. Because I don't know, like I thought of doing highest in degree first because I was like, okay, this is the highest priority guy. I don't know why I didn't think of like, spreading from the corner. I'm so
I mean, I just drew it. Like, what I did is I just tried to draw it out. Like, I started by just drawing all the connections, and I'm like, hold on, how would I build this? At some point, I realized, like, I can just believe that it'll work because they've guaranteed me that it'll work. So I just find the corner and I just build from it, and it'll work out. Like,
So you're telling me the lesson I need to learn from this contest in order to be better next time is to just believe in God.
I mean, like, you have to
Believe
know
in
what they
Jesus.
tell
Let
you, you know what I
Jesus
mean?
take the wheel.
Hold on, what? Okay, so they're saying, oh, dude, these fucking sneaky bastards.
What?
Dude, look, there's a lot of numbers. The numbers go to 10 to the 5, but the actual numbers go to 10 to the 4. So what you do is, you go 10 to the 4, you get the maximum number. You know what I'm saying? And now, you have, like, it's like you can lower n. You know what I mean? Like, this is n, but it's like, actually, this is n.
There's no way this is what's going on.
No. Like, you still have to do the fucking binary search and whatever, but you first have to realize this little trick where instead of, like, it's like the buckets thing. You know what I'm talking about? Like,
Oh, wait.
put them
Oh,
in
so you just
buckets.
convert it to like a set first.
Yeah, you first do the buckets of this.
Bruh.
So now your n is 5 times 10 to the 4, which means you still can't do n squared, but you can kind of, like, have tiny inconsistencies.
You know how
and log n,
how hilarious they would have been if they just made that like 10 to the 3 and just like for the people that see it, Lamau.
Yeah, the people that see that. Yeah. So this is why this guy first gets the max value. And then he's saying, okay, now you get the total number of pairs that are multiple of...
G, okay.
The point is...
No. G is just every unique value. Okay, let's go back. G is just any unique value in there. Get the total number of pairs that are multiples of G, and subtract GCD count for 2G, 3G. Build prefix some of these and use binary search to execute queries. So it's like some...
I don't know. There's some weird usage here. This is like a more... I mean, that's okay. I wasn't going to figure all that shit out.
2-question gang
I'm okay with
assemble.
sticking to...
That's good. That's impressive that you still get like the 3 out of 4s consistently. I need to get to that level. So I want to at least like be 50-50.
This contest, like, I knew like halfway there's no way I'm getting 4 out of 4. Like, sometimes I was close. This one was like no chance because Q3, like, I wasn't sure if I'll do it in time because I got to the idea like there was still like 45 minutes left, and I was like, okay, I know exactly what to do. And then I typed for like 15 minutes. I'm like, holy shit, I'm not even like a third done. I mean, it wasn't that much, but it's hard to do it properly. You know what I mean? Like,
right.
Like, look at this shit. Look how long my solution is. And this is like clean version. 101 lines exactly. But I guess 100 lines because the last is empty.
Yes.
You like my detection algorithm? If there is something with 2, you are corner. If there is something with 1, you are 1.
You detect. Okay, I had the idea. I was wrong direction. Oh well.
You like my functions? Solve entire. Solve
Okay.
first 2 layers.
You know what I propose,
solve
sir? We watch a movie. There's the Platform 2 released by Netflix. We go enjoy a movie, post-contest movie. What do you think, sir? Okay, so sorry about the cutoff there. I just want to say that's pretty much it for this video. I hope that you found it useful or entertaining in any sort of way, and if you did, I would highly appreciate if you left a like or a comment. But otherwise, I will just catch you in the next week's contest. So until then, ciao, my friend. Bye-bye.